I think there are a lot of questions that will need more than the simple data that he alluded to, and I think that said, there are plenty of questions that will be value added and very answerable with smaller amounts of data. The question that I have that I think is worth following up on is, the comment was made, we don't really have the mechanisms in place to get at even some of these basic things. So my question is, why don't we have the mechanisms in place? And what are these mechanisms that we don't have in place, right? So I hear about that all the time. Well, I just can't get to what I need, or I just can't get to the piece of information that we have. I know that I entered it somewhere in the electronic medical record, or I know that we have a lab that captures it somewhere, and then it goes into this ether, and then I don't know, I just can't get it, right? So if there are problems that are easily solvable with small amounts of data that are discrete or fairly easily extractable, or where we say, we know the data is in there somewhere, but we don't even, we don't know if it's discrete or how to get to it. The thing that we need to focus on is what happens in that back-end data management side of things. So I found at our organization and at many others, we have a lot of data. We don't have a lot of people who know where it goes from the time it hits the Epic system, where many people enter it, or name your vendor. Ours is Epic, but any EMR vendor, to the time where it hits our enterprise data warehouse, relational database, whatever. And so I think one thing that we have to spend some time on is the data engineering of the back end, because it shouldn't be terribly difficult to extract what you've put into it. And if your system is making it difficult to extract what you've put into it, then you can probably engineer things a little bit better. Now that may be a combination of things like doing better data modeling in a relational environment, or doing less data modeling and doing a schema on read type of modeling through a big data platform or whatever. And so there's no real right answer to that, other than it depends on the kind of data you have and the way you want to get at it. But I think the reason that we don't have these things in place is nothing mythical. It's because we don't do a great job of engineering the part between the data enters a transactionally oriented database to the data flows out into an enterprise data warehouse in some usable fashion. And so a little basic data engineering, I think, could go a long way in getting us access to the information that we need, because there's no reason that any doctor or any researcher in the hospital shouldn't be able to click on some fairly simple thing, query for a set of patients, and get their hemoglobin A1C in like 3 or 4 clicks. So if your system can't do that, and most can't, and to some extent ours can't either, then you need to think about your data engineering challenges.
Thank you. So just in summary, as we move to Ramdas Menon for his commentary, what I just heard was technical re-engineering to provide the right data at the right time, and the evaluation and adjustments for process mechanisms to actually be able to use the data. Dr. Showalter made a point of stating the big diseases that data presents obvious understanding of based on a few metrics. To supplement that, from a statistic perspective, in 2010, an estimated 150 million patients in the U.S. had diseases such as diabetes, congestive heart failure, and hypertension, and accounted for more than 80% of health system costs that year. So the process mechanism by which to utilize some key metrics to help with prevention as well as treatment, and the technical re-engineering to be able to present that data right time, right place, right person, I think is key.
Right, and let me put on my hat as the Chief Connectivity Officer, self-titled. The things I would look at are basically, one, policies. You have all the HIPAA regulations, you have state level statutes and all that, but you really need to develop policies. And we did a survey of the managed care group serving our Medicaid population, and we found that they had all the data. They had portals in place, but they were not sharing the data because they hadn't gone through the policy analysis. So policy is important. The second thing you need to be aware of, and I'm talking at a certain level of abstraction here, is that you need to integrate everything you provide, so that you need to provide everything that you have and have it integrated into the workflow. You're talking of practices, you're talking of culture, you're talking of organizations, and you're talking of individuals who really don't have a lot of spare time because they're busy. So you need to integrate into the workflow. How do you make it available? How do you convey this information? In what form? How can they digest it easily? So keep that in mind. Adoption into the workflow. The third thing I think that we need to do is we need to do a better job of actually communicating in terms of education and training. And how do you do that? You can do that by looking at certain measures. In the private sector, I would say look in terms of measures related to efficiency. In the public sector, I would look at measures related to effectiveness. What are the measures which are appropriate? What is an appropriate metric system? So the best way to get this is one way you need to engage your users is through a process of outreach, education, and training. I think those are the three components that I would focus on wearing my CCO hat.
Can I just add one quick comment to something?
Thank you, certainly.
His answer made me think of something that's sort of random, but it's interesting that when we think about policy, we are rarely incentivized to share data, right? All of the incentives that we have are incentives to not share data. You're going to get punished if you break a HIPAA rule. You're going to get punished if you let this leak or that leak. If this crosses from this side of the organization to that side of the organization, something terrible is going to happen. When we add all the real ones with all the perceived ones, where people say, "Oh, well, you can't have that." My favorite part of my job as chief data officer, somebody says, "We can't do that," and I get to say, "Why not?" The general response is, well, because you can't. Well, because HIPAA. Well, because privacy. Well, because, and the fact of the matter is, if you don't have somebody asking why not, you're going to find that you have 20% real problems and 80% perceived barriers to access, right? And it's very much a change management and a cultural change sort of thing to get people to say, no, okay, we can share those things. And I think it's interesting because it's all about an assessment of risk, right? So what's really the risk of me sharing this piece of data with you or this piece of information with you? And I think about it perhaps that way from a clinical side. So I'm a neurosurgeon by training, and oftentimes when we see somebody clinically who, we'll see them they've passed through 4 or 5 or 6 different doctors, a variety of people have said, well, I'm not really comfortable going after that tumor or biopsying that thing or doing this operation or whatever. And by the time they make it to us, there's really nobody else to punt it to, right? And so we kind of have to say, all right, well, yes, this is inherently risky, but we either have to decide we're going to do nothing and just maintain the status quo and let you go on with your disease, or we're going to take risk. And so we talk about the risk, and we have an informed consent kind of discussion back and forth. And it's the same thing with data. At some point you have to decide you're either just not going to do anything, and you're just going to let it sit there and say, well, we have it all, but we're never going to use it. Or you got to decide to have a risk-based, risk mitigation discussion and figure out, what it really makes sense to share versus what it doesn't. And I think if you eliminate the perceived risk and you deal with the risk mitigation part of things, the process of moving data becomes a little bit more straightforward or a little bit less obfuscated.
No, and so I think that point is actually underappreciated. I literally 3 months ago had the discussion with our compliance group that our initial question before we went any further in governance was, are we or are we not going to do human subject research? Because if we're going to do clinical research on our data, there are risks. I cannot make it risk-free. And if we're going to go for zero risk, then we just needed to stop meeting. Their jaws kind of hit the floor, and I went to hyperbole on purpose because we were going down this path of you can't, because there is some perceived level of insignificant risk that could, in theory, if the stars aligned, maybe possibly could. And we can't function with data at that level of conservativeness. We're going to have to take some risk, and at the end of the day, if we're not doing the research, we're not advancing science. If we're not advancing science, we're going to be doing the same techniques in 100 years that we're doing now. And if I look back at 100 years, we had some really bad treatments.
So please.
Putting aside the risk, which is not something easy to put aside, one of the things I guess I'd like to throw out, one of the problems I have with this whole concept of big data is it gives the impression that there's this one thing called big data. It isn't. And what I think, and I think the problem you were talking about, John, really fits into this, the real question to get the information you want has to do with structuring data. And with the amount of data we have, there's not one structure. People think, I got a data warehouse, now I can answer all my questions. Well, you can't. And I think one of the things that's important is to get people to understand that, there's maybe one huge repository of data, that's what's needed for production. But if you want to exploit that data, you may have to do many different things in different ways. There was a book in the 70s written, some of you are old enough probably remember this, called Small is Beautiful by Schumacher. He invented this concept of, we call it appropriate technology. Maybe what we need is appropriate data structuring as a concept. get people to stop thinking about, I got, zillions of bytes of data, that makes me really powerful. Actually, it makes you useless. And it's the question of how do you exploit this data? And I think that's not only a changing dynamic, I think it's a very deep investigation in many cases.
So we have a philosophy, both because of budgetary restrictions and because of the analysis and the way we're tackling things. We are a late manipulation model. We are taking the data in as raw a format as we can get, and we're storing it as raw in format, and we are manipulating it problem-based. Because pre-manipulation just means I have to go and undo the manipulation when someone comes and tells me what they actually want, and I guessed wrong. So rather than putting labor into that, this mirrors what's in the actual data structure under our financial system, under our EMR. The real manipulations we're doing, taking addresses and making them latitudes and longitudes, and we're really focusing on sending that raw data to partners, especially if we want a greater variety of data. So if we want census data or credit card purchasing data or 9-digit zip code, a whole list of data, we're partnering with people that are buying those in bulk because we can't really afford to do them ourselves, which is part of that risk, because we actually have a partner that we're sending almost the entire EHR except for notes. Anything that's discrete, we're dumping to them. And our privacy guys are not super happy about that.
So I would say that a couple of comments in response to your comments. One is, I think the term big data is a pretty ridiculous term. I think it's probably something that a vendor must have invented because it puts the focus squarely on the ones and zeros and the disk that it's on and how it moves and whatever. I'm much less, even though my title is Chief Data Officer, that's only because Chief Information Officer is already taken by somebody else who's been in the system longer, right? But I mean, it's much more about the information that you extract from it, right? So I mean, I don't really want to focus on all the ones and zeros that I put in a box because there's zero value in that until I start to do something with it. Okay, so I think the more sessions we have titled big data, and this is no slam to the organizer, but the more we say big data, big data, big data, the more the focus gets put in the wrong place, and it gets put on the ones and zeros that we have sitting there, and that's not where the value is. Now, colloquially, it's come to mean more than that, which is good. But I mean, it's just a misleading term from the beginning. You mentioned that perhaps we should think about multiple different structures for things. So that's an interesting comment because the arc over the last year that I've been in this role at Geisinger. So before I got there, we were a very structure-centric organization. So we had a relational database, and inordinate amounts of man hours and human resources were spent doing ETLs for every field, structuring things very explicitly, defining things very explicitly, putting it into a very traditional relational database. The problem is the data sources were growing so quickly that, I mean, we just couldn't keep up with it. And everybody is saying, I want this, I want that, I want that, I want that. And we're going, oh my God, how's our EDW going to deal with it? We got 20 people just putting data in, and every day the backlog gets worse, right? So we thought for a long time first about should we change the data model that we have this stuff in, because the data model's not working for this guy and the data model's not working for this guy, and the more we thought about it, the more we said, I don't think we're ever going to find the data model that really works for people. So let's stop looking and let's change the way that we're thinking about things. And so this is where I kind of got to jump up and down a little bit, because my preference is to work in a world with very little structure, just in general. So our data comes in lots of raw formats, and like you said, I think we can land this stuff at the beginning and access things the way we need it. I like a schema on read kind of approach because it allows me to apply the structure that I need as I'm doing it. And much of the data that we're getting now is not really structured. It's semi-structured like image files, let's say, or it's completely unstructured like free text. But if we're not used to working in a world without structure, we're going to be pretty screwed 2 or 3 years from now, because our data sources are coming less and less structured and more free thought kind of thing, whether it's coming from our own EMR text that people write, because doctors are never going to stop writing notes, right? Or from ambient data, from Facebook data or Twitter feeds or anything else we're collecting. The structure is just not there. So I would say rather than I would take it a step further, and rather than say, define multiple structures, get comfortable working with unstructured data and defining the structure for the problems that you need to solve. Now, the caveat to that is we do define some structure at an early level for things that need definition. So, like, we have to pick an organizational definition of what is length of stay, right? There's like 20 different people's opinions on how long a length of stay is. Is it from midnight this day to midnight that day, or the morning of, or the discharge time, or the whatever? At some point, somebody's got to decide on one or two. And so the strategy that we're taking now is to decide through a governance process what some of these minimal layer of terms that we need to define just so we can do business are, put them in a metadata layer that defines them as the basis, and then say, okay, now we can then go back and define some sort of model on top of that that meets the needs of most end users and makes data pretty intuitive, but at the same time, users who want to put different structure on things can have access to just that definition layer, or nothing at all if you want nothing at all, and can access the unstructured data and apply your own schema and read to it. The caveat being, you got to know what you're doing if you're doing that, because there's this fear that, oh my God, the end users are going to get to some kind of data, they're going to make an incorrect assessment, because the data is not defined appropriately, and then the world's going to end. Well, a lot of the end users are actually pretty high level who want to get into the data at that proximal level, right? And they understand the challenges of working with unstructured data and are going to fairly rigorously think about the definitions. And so I think as long as you define some of that for people who aren't so sophisticated and give people who are more sophisticated access to things, but say, hey, look, it's on you to define these things correctly, and if it's something that really affects process, we're going to take a look at how you define those things. But yeah, the idea of imposing a single rigid structure, I think, is intractable at this point.
Thank you. Sir.
One of the things that I love hearing stories about are how organizations might be using big data, small data, doesn't matter what, but analytics to truly affect outcomes in a positive way. Somehow healthcare is impacted in a positive way. We have stories or anecdotes to share.
So big outcomes?
Yeah, that would be cool.
Sure. Do you want to take comments on the last thing first?
Well, one of the things that we are doing, and remember, the governmental sector, especially Texas Medicaid, is not well known for analytics, but one of the things we're exploring right now is we are looking at pharmacy claims, and we're looking at the relationship between e-prescriptions and written claims. And what we have discovered is that, pharmacy is a good area to look at because everything is consolidated under SureScripts. So there is a trigger which, how is this claim submitted? So you can actually look at the analysis. And ever since the EHR incentive program was rolled out in 2011, the e-prescription rate has gone from about 10% to 45%. So that's probably a good indicator of how e-prescriptions, which is part of the best practice model, I'm sure most MDs here would agree with that, this program is actually making a positive impact. But looking at the data more finely, we see variations. We see variations across regions. We see variations across plans. So that gives us what I call actionable information. So we can target specific groups. We can target specific areas. We're also looking at the relationship between the mode of prescription and pickups. And what we are now finding is that e-prescriptions are less likely to be picked up than written prescriptions, which means adherence, compliance. So those are preliminary indications which also suggest to us intelligence for information that can be worked on. So that's one way in which we're using big data. And then we are also correlating the pharmacy claims with the general claims which is coming in, and other kinds of information such as immunization data that is collected from our public health folks, as well as lab results. And, so as we progress, make more forward progress on some of the analytical questions, more questions come up. So one other final point I want to make out is, when you're doing analysis with big data, you got to keep science in mind. The way people who talk about big data talk about issues is, oh yeah, let's look for patterns, let's look for this, let's look for that. And most often, I feel that these end up in rabbit holes. Meaningless. So you got to make a distinction. Okay, how can you wed the principles of science into big data analysis? You need to have hypotheses. You need to have a better understanding of what statistical significance means or substantive significance means. All right? And that's the kind of research. And my concern is that we are divorcing big data from science, And that could lead to a lot of rabbit holes.
But I just have another question. And that's what you just quoted about e-prescribing is fascinating. In Illinois, before our HTRAC got adopted, we were starting using Medicaid data, started informing different ACOs about when people, picked up a need prescription, picked up a prescription. So why? I mean, it's interesting. I mean, is it the piece of paper that helps get people to pick it up? I mean, which
You have to do something with that piece of paper. I would extend that use case a little further, though, back to the process mechanism that can utilize data that's made available. Why go anywhere to pick up your prescription? So you get an e-script, you get the delivery of the script, and you utilize telemedicine, telehealth, whatever your preference might be, to have some sort of conversation with the pharmacist if you have questions. You don't really leave your home. The drug shows up at your house.
for people who have houses, but for homeless people or others,
Fair enough.
And mind you, we are working with Medicaid, which is indigent population, hard to reach, highly mobile. So some of the results that we generate from this are going to really inform other areas of the healthcare sector.
So the mechanism for delivery then of the RX
Right.
is needs to be revisited.
And one of the issues which I want to highlight is that Medicaid population again often is culturally very complex. Hispanics in Texas, for example. So that introduces another level of diversity and complexity to the equation. So cultural competency is also an important factor.
Yeah, and one of the things with e-prescribing that's underappreciated is that you have to choose your pharmacy. So if you say, I go to the CVS on the corner of whatever, and it's 7 o'clock on a Saturday night, and you got there and they closed at 6, if you have a paper script, you go, oh, the Walgreens is 2 blocks down. You go to the Walgreens, oh, they're closed. Oh, okay, I'll go to Walmart. Walmart was open, and I got my prescription filled. I made 3 stops. If we e-prescribe it and that pharmacy is closed, you're done. You're going to have to find another CVS because we already committed you to a chain, and I can't change where that's going.
The moral of that story is just pick Walmart first, because they're open.
Well, I could in theory pull it back. So I, as the physician, could pull it back. I could go and I could change it. I could resend it. But if my office is closed, you're totally out of luck.
So if I have a personal health record and the e-script shows up in my PHR and I can take that with me, would that? No?
It's probably not only is the pharmacy open, which is something you need to check, but also is drug available, because in some cases it's not. That's
Yeah, there is no, with e-prescribing, there is no, I walk in, you go, oh, I don't have that, walk across the street to, and actually where I live, I can walk across the street and go from CVS to Walgreens, they're literally across the street. But if it's e-prescribed, it is stuck with one unless my provider changes it.
So I want to address the question of, name a couple of cool things that you've actually done with data. So I'm going to give 2 examples. One is a solution that is reasonably along the pathway to maturity for us, and is something that is not particularly heavy in analytics, but yet is making a very easy to identify difference. The other one is something that's sort of more hot off the presses, that's more analytically oriented. Both of them use, I think, a combination of big data and small data. So the first one is some work that we've been doing with our radiology reports via natural language processing. So the question is, are we missing things that should get followed up on, right? Everybody who's read a radiology report knows that the radiologists read every little tiny thing that they possibly can, say, cannot rule this out, maybe this, possibly this, incidental comment is noted for this or that. So we started taking some of the things that are frequently commented on, although rarely are the primary purpose of the study, and creating a system for following up on them. So what we do now routinely is every radiology dictation is sent immediately to natural language processing engine, and is available in XML marked up searchable form within a couple of hours of it being completed. So we had that going for a year or 2, and so we were creating this big repository, and people were trying to figure out what to do with it. One of the early use cases was we looked at abdominal aortic aneurysms, which are incidentally identified fairly frequently on abdominal CT scans that are done for other purposes, and the radiologist will say, note is made of a 4-centimeter abdominal aortic aneurysm, clinical correlation recommended. And the doctor who ordered the study is looking for something else and says, that's nice, and looks at what they're they're looking for and says, okay, perfect, well, the patient doesn't have an ileus, the patient doesn't have a bowel obstruction, the patient doesn't have whatever. That's what I really ordered the scan for, so okay, great, and probably their primary care doctor will take care of that other thing or whatever. The problem is a lot of those get missed. So we now have a system in place where essentially every positive syntactical case for abdominal aortic aneurysm is downloaded and set for, in this case, manual review by a nurse informaticist or a nurse specialist who decides if this is somebody who should be followed up on or not, and if so, they're automatically keyed into the vascular surgery service to follow up on the incidental finding. And we've had a number of patients who've gone on to have definitive management of these things, whether it's through stenting or surgery or whatever. And so we assume that there's both a complication reduction, a risk reduction, and a cost savings associated with finding the thing early. And that's just through free information that was being put out there that nobody was accessing. We updated that system a little bit. I actually did it in my own sphere in neurosurgical oncology. So when I sort of built generation 2 of this with my team, so we built a generic tie-in to the API that our vendor for the NLP provides, so that we can basically query any search term in real time and automatically download into a NoSQL database the reports, all the markups associated with it, a bunch of other things, right? And then so we're doing that for brain metastases now, because we found that in our area in particular, there were a lot in central Pennsylvania, so the folks who were seen at the main hospital get keyed in very nicely to our multidisciplinary brain metastasis clinic. The folks seen in the periphery still get subject to sort of an older school management of brain metastases, which is often go straight to whole brain radiation, which is not really standard of care anymore, but doctors who trained 20 years ago tend to think of it that way. And so we were missing a lot of people who we could have intervened on earlier with more modern methods and increased survival. So basically everybody who gets a brain MRI done now, it's scanned for the mention of metastatic disease. It's pulled in through our generic API so that this can be done with any disease essentially by just changing a couple of keywords in the API code. And in this particular case, it goes directly to the nurse navigator who runs our brain tumor clinic. And about half of them are people that we know anyway. They're getting follow-up for their brain metastases, and they're seeing us in clinic this week and whatever. The other half she looks at very quickly and in 5 minutes can decide, of all of the brain imaging done this week, are there any that we're missing who we can just send a note to the primary care doctor and say, hey, just so you know, we've got a resource available for you. If you want, fine. If you don't, fine. We're not just reaching out and grabbing patients and sucking them into our system, ad lib, but it allows us to communicate with people who ordered the imaging that, hey, we saw this finding and we've got resources available to provide really, modern standard of care therapy for that if you so choose. And we've gotten very favorable response to that. So that's really not a complex analytic thing. That's purely a data engineering thing. It's how do we, it's applying some basic NLP, some basic markups, some basic programming to get it from point A to point B, some basic, semi-automated screening followed by a secondary layer where a human being looks at it to do some of the things that it's easier for the human being to do. But there's nothing in there that I would call complex analytics. It's just taking information that was previously getting thrown away and left on the floor and helping to connect patients with more appropriate resources. The second one is literally something we're working on right now actively. So I'm trading emails with one of my programmers about it yesterday, today, whatever. So we noticed that our hospital-acquired infection rates are higher than the average for our group, all right, for our class. And so this has become an area of interest of quality improvement and other such things. The first response to this was to sort of implement all of these blanket clinical protocols where everybody who's got this or that or that or that criteria, you got to wear a gown and a mask and a this and a that going into the room. You got to clean all the rooms with an extended level of cleaning. Right? Very costly to do all of this. And it probably hasn't made all that much of a difference, to be honest, because it's intervening at a point where probably you're not really treating the problem of how these things are spreading. So our infection control people have been sort of racking their brains on this, and this came to my data science group. So one of the fun things that I do is I also lead our data science team. So I've got 3 PhDs who are applied mathematicians and theoretical mathematicians, and 3 programmers who are very versatile programmers, and we kind of tackle the hard problems that people are having trouble solving. And so this came to our attention as, geez, we're not sure what we're doing wrong, but we know there's a lot of data about this. In fact, they had engaged engaged in it with a vendor who is taking all of our admission transfer information, pulling it down, mapping the room numbers to people, and then spitting out these huge databases that were almost completely unpopulated with just a few things like this guy was in this room at this time, and then nobody else on your list of infected people are ever in that room. And our infection control people said, well, we can print it out, but we have to put it on the whole wall, and then we're trying to match people up like this. So with some simple data engineering, we were able to make that much more consumable. But then we took it another layer, and we're using this as an example or as a use case for a graph analytics engine that we're building, where we can actually look at proximity and degrees of association between patients who have these infections, so we can follow them through spatiotemporally, in what rooms are they at, in what time sequence, and using graph algorithms try to figure out which ones are really etiologically or statistically at least related to each other, which ones aren't. And then, this is sort of a proof of concept that we're doing right now to prove that we can gather a lot of information from this big, vast pool of stuff that people didn't know how to use before. And then what we're going to do is start to drill down on those people that represent the central nodes and their proximal primary connections to figure out why it is that they seem to be origins of infections that are then spreading to other people in the hospital, and why this guy over here who also has an infection is not an origin. So this is something that we're doing literally right now, and I think we can tell already by the way that our graphs are looking that there's clearly something there. There's clearly something that we're going to be able to drill down on, and so I don't have a resolution to this yet, but this is an example of a lot of the buzzwords in big data right now that people are using. So we're combining a lot of structured and unstructured data. We're combining throughput data with clinical data. We're doing this in a Hadoop-based setting, right? We're doing graph analytics and graph databases. So these are all the things that people like to talk about as, very trendy, in vogue things for big data applications right now. And I think this is a great clinical case for that, because what we're really talking about is degrees of relatedness, degrees of association with the spatiotemporal component that we have no real understanding of why it is this way for some of them and not for others. So it's, I think that's a good example of another case.
So, first of all, I'm in this because eventually I believe I'm going to sit on a panel that's the great knowledge and awesome outcome panel, as opposed to the data and analytics panel. There should be enough time in my career for that. I'm hopeful. I think there are two analyses that are really beneficial when you look at trying to get good outcomes. One of those is the time series analysis. We have timestamps on everything in the EHR. They are utilized in analysis, I don't know, less than 3% of the time, but they're incredibly powerful. And to illustrate that point, we did a sepsis project when I was at Penn State, and we took this is the course that you should follow to respond to a sepsis patient. These are the known timelines from the research that impact survival. Did the analysis and went, wow, when we talked about this, said it should have taken 15 minutes in the ED to give antibiotics, and it's taken an hour and a half. Took it to our multidisciplinary group and said, you all have to get faster. This is ridiculous. And luckily we had a pharmacist fellow in the room that went, yeah, 2 slides ago, you said we use this antibiotic as our primary antibiotic. I said, yes. They said that takes an hour to make. And we went, so what you're telling me is you're not going to make 15 minutes. So we went through a big project to redo our formulary. We select a shelf-stable thing that can be in the ED that immediately, as soon as it's ordered, the nurse can go over to the drug cabinet, pull it out, hang it, give it. Dropped our average time to antibiotic by over 80 minutes and reduced mortality 37%. It never would have got there without doing the timestamp analysis. And I don't see it used very often, and we just kind of assume that we have good processes and we're doing things like we should, or we're within the guidelines. So, we're giving DVT prophylaxis within 24 hours as the guideline, but the evidence shows the earlier we give it, the better. So if we can move that from 23-hour average to 11-hour average, we'll reduce blood clots. We also did that at Penn State. Right now, we're more on our hot off the presses kind of things. We're working with a third-party vendor to do more eigenvector Google search type analytics, sucking in environmental data, zip code data, consumerism data, working with them. And I picked the right thing or the wrong thing depending on what conversation I'm in and who I'm talking to do first. But we decided to push them and make them prove their claim that they could tell me who was going to have heart attacks in the next 12 months. Because our normal scores are a decade horizon, and it's, you have a 30% chance of a heart attack in the next 10 years. Not shockingly, that doesn't motivate a lot of our patients. When we did our prospective modeling, we were able to identify the 1.5% of our population that had a 70% risk of MI in the next 12 months. So that was awesome. The bad part was I went to the cardiologist and I told the cardiologist, based upon using this math that you've never heard of and pulling in zip code data, I can tell you who's going to have a heart attack in the next 12 months. I almost literally got laughed out of the room. Managed to say fight through the initial reaction. And they went, well, that's fantastic, but we really need to prove this, so start scoring our patients and we'll see what happens over the next year, which has me very frustrated because we have patients that I feel like we should probably be intervening on, but I don't have clinicians that have faith in the results enough to actually act. We're going to break it at 6 months and hope that the trend is significant enough that we can at least get care coordinators to start meeting with these patients and reviewing what they're doing and get real smoking cessation, real blood pressure control, real diabetes control to the group. But it is such a novel concept and so far outside what we expect to be able to do with transactional data that there's just disbelief.
So to get the trend to be significant enough, people have to have heart attacks.
Yes.
But after identification, did you follow up with those people and notify them, and then did that result in some?
So we haven't done anything with it because as we got through our discussions, our clinicians don't have enough faith in the result to inform or notify off of. And we're in this catch-22 of, in an evidence-based model of healthcare, I haven't scored people and followed them. And we're used to scoring people and following them for 10 years. Just because the math says does not put us in a position where physicians are willing to act. We are at potentially just as much harm if we stress a person out and they're not really at high risk, or if we tell someone that they're high risk and give them a medication, they have a reaction and they die, and then they come back and say, what did you, the lawyers come back and say, why did you do this? We go, oh, we had this great mathematical theory, we changed their medication. Unfortunately, they were allergic to aspirin and died.
So it's this kind of innovative thinking that can change the game on preventative, encounters. The data that you're referring to in this model, was it all clinical? Was any of it provided by the patient?
So it's all inpatient. So we're evaluating our inpatient. It's all inpatient transactional information, lab, administrative, demographic, combined with commercially available data sets based upon geolocation.
Can you at least follow, making predictions, are you following up to show people, here's the
Yes.
predictions and here's the
Yeah. So we are prospectively following them now, and we're not really doing research. We're really viewing this as a clinical intervention at this point, because it was always our intent to have this be a clinical intervention. But we are scoring them, and actually we have it fully integrated with our health record. So we are sending data every day. They're churning it, and we are sucking it back in discreetly, so that we have a score every day directly associated with our patients, and we have some proof of concept decision support tools built around it.
So I would add just very quickly that I think your point is exactly right. Time data is extremely valuable, and it's very underutilized. This is one of the areas of interest of my data science group, because the first example that you mentioned with sepsis, at least there you have some guidance. We want to give this drug by this time, and let's look at our timestamps and see if we're doing it. What do you do when you have no idea what the temporal association with two variables is? So you say, I have this lab value here at time X, I have this value here at time X plus T1. Then I have another result where I have the same thing in time x, and I have it over here at x plus t2. Does that mean anything for the predictive value of something or the likelihood of an outcome or something like this? We have no idea what the actual temporal intervals are. So we've started studying this problem structurally, which we've had to approach with a variety of neighbors-based algorithms and other such things, and a lot of data, because you have to try and find people who look like they have the things that you're studying spread out that happen to spread out in the same way as another one, so that you can cluster them and whatever. So our data sets for these are usually on the order of about 500,000 interactions or 500,000 patients or something like this, or discrete patient episodes, right? And we found some interesting stuff with it. So, for instance, we took a hard problem like, can you predict who's going to die in the next 6 months, taking all comers, right? And if we just used clinical data, we were at about 53%, so not much better than flipping a coin. When you added a temporal component to that and looked at neighbors-based clustering with a temporal component, we're up in the high 70s for specificity, which is not bad considering it's such a complex problem, right? And so as we start to pare down on that a little bit more, we'll get better. So that's unpublished data, by the way, as a disclaimer. So don't believe it yet, I guess. But the point is, adding a time-based component is really valuable, and there's a lot of cool stuff that you can do with that, and it's underappreciated. But it's one of the things where big data is going to help, because we have just gigabytes and gigabytes of logs and timestamp data that everybody just throws away and says, just give me the med list, give me the problem list, give me the whatever. And those log files are very important, actually, or at least have the potential to be very important.
I had a question.
Yes.
You talk about, there's good data, bad data, and I think the data that you use is probably good data because it's transactional. And you mentioned problem lists and meds, and I think part of the reason why clinicians don't have faith is because they probably experience some sort of data, but that's not accurate. Like epic reported workbench, there's a lot of, I'm sure there are a lot of reported workbench reports that probably aren't accurate for whatever reason, maybe for bad data engineering. So I feel like, how do you create that end user culture of good data, data diligence, I guess is the way they use.
So I'll give the short answer, which is our transactional data and the stuff we're sending is problem list. It's not good data. My defense to that is that we have math that doesn't care.
Exactly. So I love dirty data, because if and I've got a talk that I give about this, and we've got a project that's going on right now about using bad data, right? And it turns out that it almost doesn't make a difference, right? So we have had people at our organization who have spent probably hundreds of thousands of man hours cleaning data, right? And my point is, I bet that's a useless exercise, a pretty useless exercise, because if you know the question that you're asking and you can measure the consequence of the consequences of the uncertainty in the data that you have, you can figure out not just what my estimate is, but how reliable the estimate is. So my group is far more interested in standard deviation, variance, and uncertainty estimation than even in mean prediction, right? Because anybody can give you a mean from any set of data, good, bad, or otherwise, right? The question is, how certain am I in that? So we spend most of one of my PhDs is a nuclear physicist who did uncertainty quantification for nuclear reactors. That's why I recruited him, because he knows uncertainty quantification, and that's fundamental to every single thing that we do, right? And so one of the projects that he's working on actually is we're saying, okay, so let's study that problem of dirty data by looking at the consequences of decisions that we make about how we manipulate that data. So let's say I have a set of data that's 85% sparse. What would happen if I filled it in? How much would that really affect the study, the endpoint outcome? What would happen if I interpolated this data? What would happen if I eliminated these kinds of things? What would happen if I could say that I know this volume of data with certainty? So we can do a lot of this under simulation and other such things. And to be honest, if you use the right algorithms, if you structure the questions correctly, most of the time it doesn't really make a heck of a lot of difference having amazingly clean data versus dirty data, because, like you said, most of the algorithms don't care. So I think this is one of the cultural things that is very counterintuitive to clinicians to say, oh my God, if the definition of diabetes isn't right, I can't possibly get the right answer. Well, correct, there will be some times where you don't get the exact right answer, but when you look at it as a big picture sort of thing, you'll get a pretty good answer much of the time, and that's very much better than nothing, particularly if the only other alternative is to spend millions and millions of dollars and millions of hours updating every piece of data. You're fighting a losing battle, because you can't do it for all the data that's coming in anymore. And while it may be better, it's only better if it's tractable. And if it's better but impossible to do, then I'd rather go with the thing that at least gives me a right answer a decent amount of the time and helps me know the degree of certainty with which I can say, for this particular estimate made for this particular patient with this particular problem, here's how confident I am. Because really life is decision making under uncertainty, and our goal is to measure it.
So I just want to make a point that we have 5 minutes remaining. Please continue, and we'll wrap up with a final commentary by the panel.
So this could be my final comment, because this is, one of my goals is leaving people. So for the last 60, maybe 70 years, we've been focused on biostatistics when we talk about analysis. And we're looking at p-value. P-value is less than 0.5%, which means that, 0.05, which is 5%. So there's less than a 5% chance that this difference was due to chance. It's not really useful. It was never really useful, but it was based upon going from a cohort to a population. When you're analyzing the population, the p-value doesn't matter. If I have 1 million people, the p-value is going to be very low. What I really care about is the positive predictive value of the algorithm, or the negative predictive value, but generally the positive predictive value. How many times out of 10 when this algorithm says it's true, is it true? If it is 9 out of 10 times, I care. But even more importantly, it's what is my intervention. So if it's 5 out of 10 times in my intervention as I do a survey, and doing that survey gives me 9 out of 10 times because of follow-up, because I found that 2 out of that 10 that are actually effective, but I don't put you at any risk, because all I do is send you a survey, or I pick up the phone and call you, that's what I care about. And as we get to analytics, there is a major battle right now between biostatistics and analytics, because we're focused on predictive value and they're focused on p-value. And most of the biostats I talk to do not understand the difference. And clinically, what I care about is the likelihood that something is true, or the likelihood that something is or is not going to happen.
I just want to dwell on one issue, which is the relationship between data analysis and getting actionable information out of data analysis. That's an equation. So just think in terms of an organizational pyramid. When you go to talk to the CEO, you probably get 5 minutes of your time. If you talk to somebody below him, you'll probably get 10 minutes. So you need to really be communicating effectively. So, so what I'm trying to suggest here is one of the issues and challenges we had to face is that we need to do a better job of communicating the significance of our findings, whether it's substantive or statistically, to the appropriate audience, the key decision makers, stakeholders, policy wonks, or whatever you want to say. So the point I'm trying to make here is, one of the reasons why clinicians they may not understand what you're trying to say or may not buy into what you're trying to say is because you're not doing a good enough job in terms of communication. So information dissemination is often is an area that we don't pay a lot of attention to, but I think in terms of healthcare, it's very, very important.
So I think that comment couldn't possibly be more accurate. I think it's, a ton of what we do is change management and is helping people understand not just, here's some cool new toys that we can play with to get you different answers from, but why do I think these are better? Why do I think that this is something that you'd be interested in? Why is it important that we put this infrastructure in place? What does that really mean to the patient, right? Because the CEO is focused on the ultimate end user of the healthcare system. So we have to be able to couch things in that language. So I think that's totally true. And by virtue of the fact that there's nobody else to do it, we are sort of the agents of change management in this data-driven culture. So I think my closing comments would be, I think we talked about a couple of things that are all very important to me in my role, and I think we've hit on or touched on a variety of them here to get people thinking going forward. So one is, I can't say enough how important having an organizational data strategy is that syncs with your business strategy, that syncs with your IT strategy. If you don't spend time thinking about what your organizational data strategy is, then you're just going to be doing a world of one-off use cases that don't generalize and where the return on investment is proportionally much lower than it could have been if you had just applied some thought going into it. So organizational organizational data strategy is one of the things that I talk about a lot and think about a lot. 2 is infrastructure. The whole big data thing is just part of the consideration, so it's all just about making the information available. And whether you're in a relational environment, a Hadoop environment, a structured or unstructured environment, whether you're tying in high-performance computing-based things because you have things that are computationally expensive, not just big data, whether you're outsourcing things to the cloud because there are things that it doesn't make sense for you to store on your, in your own organization, you're going to have a strategy about how your infrastructure meshes with what you want to do with the data. And so it's important to think about how you put those two things together and how you build an infrastructure that's really designed to deal with the information that you have in your organization and specifically tailored to producing what you want to produce with it. I think data engineering is important and is often underlooked. A lot of the simple solutions don't require any analytics at all or very, very basic analytics if you just manage the data correctly and put it in a way that people can consume it. There's simple data engineering and there's inordinately complicated data engineering, and there are use cases everywhere along the perspective for that, but I don't know of many healthcare centers that have a data engineering department or a data engineering group in there somewhere in their IT structure, and I think a lot of the problems I've seen stem from that. I think application is very important, so you've got to focus on not just why you can do things, but where you're going to use them, and translating from mathematical result to actual implementation is very important. That's not what I particularly specialize in, but I'm arguing for building a group that really does that, who is very much end user focused and can bring the results that the math guys and the data engineering guys produce to the end user. And then the last thing is analytics is changing. I think we've heard a variety of examples of that. The era of the p-value is leaving. Doctors don't want to see that happen because it's not what you're taught. It's not, and it's not what you're familiar with thinking about things in other ways. Plus the p-value is very understandable. But as we move into large data sets, and so the situation, the large p, small n problem, where you have many more features than you have, and many more patients than you have things that you're studying, there are ways to fudge the p-value. There are lots of corrective measures for it, but at the end of the day, what you really need is a difference in the way that you think about what you're predicting. And in my assessment, a lot of that, however you decide to describe it, whether it's looking at positive predictive value, whether it's looking at confidence intervals, it's all some sort of measure of the degree of certainty that you have in the prediction that you're making. And I think that's, we're at the very early stages in healthcare where we're switching to a culture that has to use that, because that's part of, it just doesn't work any other way with the kind of data that we can now access. P-values are great for a study of 2,000 patients where you're tracking 40 variables. They're not great for a study of 2 million patients where you're tracking 4,000 variables. It just doesn't work that way anymore. And so we have to, communicate that to our end users also. And so in many ways, it all comes back to we've got to do it right, and then we've got to communicate it right. And we've got to be strategic about how we do it.
Thank you. So a number of takeaways from this discussion. Hopefully you've received some value from the dialogue. I heard a lot of good commentary, some things that I will take away, especially the idea of the collaboration of big data and small data. And what Dr. Marco just said about data strategy, I think is keenly important when you're looking at trying to make any type of impact on outcomes in the clinical environment. So I want to take a moment to thank the panel for their time and their expertise, as well as the audience for your questions.